Hello everyone, welcome to another video. My name is Zach. In this video, we're going to demo background tasks or background services in .NET and how to implement them in your web application. This is sometimes known as a fire and forget task. And if you're already familiar with .NET, you might be aware of libraries such as Hangfire and Quartz.net. However, neither of those libraries are MIT open source. So here at Raytha, we're committed to using all open MIT open source third-party libraries, and none exactly fit the bill that we needed for background tasks. So we ended up writing our own using .NET's hosted services. So we built our own infrastructure, which you're completely free to use. Go to our source code, check it out, raytha.com, if you want to see or just straight up use the same infrastructure that we built in your own projects. In this video, we're going to cover how to use it, how to implement it. It's going to be going through a lot of code. So this video is expecting you to have a rather strong background in .NET web development. And if you have that and you're looking to learn a bit more about background tasks or perhaps build your own version of a background task manager, then this video is for you. So stay tuned and see how we do it. Now, a common use case of background tasks is exporting data, a large data set to CSV. Maybe there's just so much more data that is reasonable to pull within a web request that is expecting a response in just a couple seconds. So maybe there's tens or hundreds of thousands of records and it's going to take minutes or even hours to produce the report. But the user still needs to take some kind of action to kick that report off. Here in Raytha, we have a functionality called export to CSV. So I'm going to click that, and we're on an admin view, so you get to choose as part of your CSV export. Do you just want to export the columns that were here in this view? We can choose our columns if we want. Or do you want to export all the columns attached to that data type? And we're just going to click all, and we're going to click begin export. And here we also get a progress bar. And then we only had 2 records in that type, so it's basically instantaneous. But if there were tens of thousands of records, we would probably see more progress along. And then we can also see messages pop up here to inform the user even more granular messaging if we want to take it to that level. So we have that capability as part of our infrastructure, but ultimately in the end, we're looking for just a simple CSV and it exported out exactly as we wanted it to. So we're good there. So the rest of this video, we're going to go into the Raytha code base and walk you through how we built this functionality so that you can learn and how to either build on top of the Raytha platform yourself if you want to also create your own background tasks, or just dive into the Raytha code base and grab what you need and port it over to your own project. All right, we're in the code base now under the content items controller, which is right here in the admin controller. So the content items, and then there's 3 actions that are pertinent to the functionality that we just demoed. We have the begin to export to CSV, and this just takes us to that view where it outputs that screen to the user so that we can make that choice. And then here's the actual post request when the user makes that decision about whether to export all columns or just the columns from the view. And that's what this model is for. So we can just take a quick peek at that definition. It's just a Boolean value. And then here in Raytha, we have our own way of injecting the current view as part of the model. So all sorts of helper functions, but really just for this video, all we care about is whether they chose to export just the columns views or not. And Raytha uses CQRS, command query pattern, for its architecture. So we have a command to kick off the beginning of the export to CSV, and we have our mediator, and it's awaiting a response, and we'll dive into the next layer in just a second. But once it gets a response, basically it's successful in kicking off the report. It's going to redirect to the background status view, which is over here, and it will output a view, and then it can also output a JSON version of that view, because we will be polling this endpoint for status updates, what percentage complete it is, and all of that. That's all part of that progress bar that we saw in that demo. But let's go in to this command, begin export content items to CSV. This is where all the magic happens for implementing background tasks on the Raytha platform. So I'm going to right click and go to definition. And where is all this? So it's happening in the next layer, which is Raytha.application. And we'll go to content items, and then we see here begin export content items to CSV. So that's where we're at now in the code. And part of this video is to demonstrate, yeah, Raytha is a large code base, but especially if you're a new developer or a junior developer and trying to, and you're faced in your own job, a huge code base, and you don't even know where to begin, the trajectory of this video is how to navigate a code base to uncover how everything works. So there's something to be said about, starting at the top layer and going each layer down and figuring out how it all comes together. Here's our command, and this is basically just the payload being passed the application layer. And then here is the code to actually throw it onto the background queue, we'll call it, because we have a background task queue. This is injected through dependency injection. And here we're just getting the data for the view. And this line of code where we're saying, hey, take this background task queue, and put this request, which is basically this command. It's just the payload that we're passing to the application layer. Take that payload and run this background task. And this background task is actually a child class. These are all child classes. You see here, public record command. They're all child classes under this begin. And that's just my personal preference of how to do this, but you don't have to do it this way. So I like it because it keeps everything as part that's contained in the same file, basically all relevant to the same functionality. So we're saying run this background task with this payload that comes in, the view ID and the columns that are chosen. That's it. We're just saying put it on the queue and run it when you can. And we're getting back a job ID. But here's the actual background task that is shown here. And there's a lot going on here because there's all this functionality of pulling the data and generating the CSV file. So there's a lot of code here that is not really like in scope of this video, but we're going to cover some of it. So we're injecting a whole bunch of stuff like the database and a couple other things. But what's most important is that this background task implements the iExecute background task interface. Okay. And if you implement the interface, you have to have this function. And this function has the job ID, the JSON element args, and what this is the payload of request, but it's coming in as a JSON element, okay? And a cancellation token. So really, we only care about these two things. This is the job ID, and this is the payload that was passed in from here. Now, why is this a JSON element args? That has to do with how the infrastructure runs this background task. Ultimately, it's taking this command and JSON serializing it and storing it in the database, waiting for a thread to pick it up and run. So when it picks it up and runs it, it converts it back from just a JSON string into a JSON element object in which we can just grab the values. So that's all that's happening here is it's just being converted into JSON and then being converted back. But we need to have these two lines of code to actually get the values out of it. So that's just how the pattern has emerged from this. I don't know if I think it's that great. There probably is a better way to do this. I was thinking maybe just dynamic objects, but maybe we revisit this in the future. But for now, this is perfectly sufficient because it gives us everything that we need in order to run it. Now I'm going to skip some of this code, which is really just grabbing stuff from the database and verifying the sort orders and views and columns. But what is important is this line of code. Because we get the job ID over here, we're told, hey, this is the job that's running. And because we get that, we have the ability to grab the job from the background tasks in the database and we can update it. And that gives us a lot of power. So we can say task step 1. Basically, this is saying, hey, this is step 1 of this task, okay? And we can use the status info, which is just a string, and we could just put in any messages that we want. Maybe we want to use this messaging later to inform the user in the web user interface. And we can also specify the percent complete. And we can update the job and save it. So as this task is running, we can update these properties and save them back to the database. Okay, so we have all this code, which is really just going through and getting all the values in order to populate the columns and rows of the CSV file. But you can see as we're progressing through the values, we're updating the task step. We're still in step 2, so we could say, hey, this is all step 2, but maybe the percent is being updated. So we get to see the progress bar move along at different intervals. And then once that is done, we can update it task 3, status info items pulled, generating CSV. So that then gets updated. And then we're generating the actual CSV file itself. We're uploading it to our file storage because we have some file storage helpers to give us what we need on that front. And then we can say the final step, maybe it's step 4. We're at 100% complete. And we can JSON serialize the media item, basically the file we uploaded, the CSV file, and we're just putting that here in this string. So we're taking the final status info is a JSON serialized version of the media item and updating it, because then our user interface can read that JSON and redirect the user to the URL for that CSV file so that it gets downloaded automatically. And that's not everything. Because this is injected, we do need to go to our configure services, and you'll see here that we said services.addScoped, and then we passed in that background task class. So this is injected as part of a dependency injection. So that means for every background task class that you create that you want to use and in queue, you would add it as well. Here, you could just list them all that you need. So we're going to go back to the content items controller, and this is the endpoint where we say, hey, what is the status of the background task? Because in JavaScript, every second it's polling, hey, what's the status? What's the status? And what we're doing here is we have the string ID, which is the job ID, because you saw here we get the job ID when we enqueue it right away, and we're returning it to this view. So now we have the job ID, and because we have the job ID, we can then make the polling request. So that's what this is right here. And we're making a call to get background task by ID, which is a query. And that query is under background tasks, get background task by ID. And all it's doing is getting that background task and returning it. But don't forget, this background task is being updated as we are doing our long-running task, because we have that job ID and we're updating the status, the percent, and all of that. So that this is getting that current status. So let's go back. Now, if we go to the views, we can find background task status. And this is where it is updating the status. And we also have basically the JavaScript that updates this section and the progress bar. We have, that would be here, Raytha admin JavaScript, because we use Hotwire, controllers, background tasks, status controller. And this is the JavaScript for basically just pull and update that user interface with the status. And if status info is parsed into a media item, then redirect that user to that CSV file. So that's what's happening here. That's the final, that's how it all gets wrapped together. It's just JavaScript in the end. All right, the whole first part of this video is how to use the existing background task infrastructure, how to consume it, how to create your own background task, and how to poll it for updates. But we haven't shared anything about how it works under the hood. So if you're just looking for how to use how to create a background task on the Raytha platform, then you don't need to watch the rest of this video. But if you're interested in how the architecture was actually built to support background tasks and maybe implement that in your own project outside of Raytha, then definitely keep watching. So the first thing that we have is under entities, we created an entity called background task. And the background task has a couple different attributes. For example, error message, args, which is the payload that we talked about a little bit earlier, the status, whether it's enqueued, processing complete, or it errored out, number of retries, which is going to be used in the future, is not currently being used. And we have percent complete, the status info, which of course I showed, completion time, last modification, and task step. So these are all, a lot of this already looks familiar from the earlier parts of the video. But what's important here is to know that as part of the requirements for Raytha, we want to limit the number of technologies that are required to deploy the Raytha platform. All you should need is the Raytha codebase and the SQL Server database. That's it. We don't want to implement another one like Redis or RabbitMQ and other kinds of queuing systems. We want everything to be self-contained for ease of deployment, ease of building. And that is why this is a table. It's an entity running alongside all the other tables. So when a background task is enqueued, it's inserted as a record into the table, and the status is updated accordingly, as shown here. Now let's head back up to the Raytha.application project, and under common, we have some interfaces that are defined here. And we have iBackgroundTaskDB, which just has one method for DQ background task. And we have background task queue. This is what we saw earlier when we injected it into the command to enqueue the background task. So we see enqueue here being that this is what we used earlier, but we also have DQ. We in addition to all of that, we have the iExecute background task, which is the interface that our background task class, that is where all the business logic is defined, implements this interface. And that's what the execute. So this is all the stuff we already covered. So these are the interfaces that are defined. Now let's head over to the infrastructure project, Raytha.infrastructure. And we have a directory called background tasks. We have a couple things in here. So we have the background task DB, which implements that iBackground task DB interface. We have background task queue, which implements that interface. And then we also have queued hosted service, which inherits the .NET background service. So this is a .NET service, like .NET. This is part of .NET Core library. The first one I want to show is background task queue. That's this one right here. And this one's actually kind of simple. So what we do is we inject the database, the entity framework database. We will also inject the iBackground task DB. And that we're going to cover that in a second. But the enqueue method, all it's doing is generating a new job ID, which is just a GUID, and it is adding a new record into the background task database table, new background task, name of assembly. So this is the remember when we were enqueuing the task, we put in the actual class name here. It's because these are generic types. So we're saying get the assembly qualified name of that generic type that's then defined, and then serialize those arguments. So I talked about how we JSON serialize those arguments, and we put it as part of the database. So that's all that's happening when we enqueue a task. We're simply just adding a new record into the database table, and that's it. It's just the name of the class and the arguments that go along with it, and it defaults to the enqueued status. as we saw in the Raytha.domain entity. Now, dequeuing is a bit more tricky because when we dequeue a task, say, hey, I want to process this now, we need to go to the database and grab the next task that is enqueued waiting to be processed, the next one that's available, and get those details and then return it back to the background task processor, which we'll cover in a second. But why is this different? So this is important to understand. This code up here just adds a new row using entity framework. This is basic.net right here, but this is different. This uses the background task DB, which was injected here. And it's also encapsulated by a lock command. Now, this is where things get very difficult when you're building your own background task manager, because you have to worry about parallel race conditions ultimately, because you may have multiple hosted services that are looking to dequeue stuff from the database, and they might step on each other, and you might end up dequeuing the same task multiple times. So then you're processing data on the same task in parallel, and it might cause issues. So this lock basically says, no, only one thread, or essentially one service, can access this line of code at any given time to dequeue a task. Okay, so let's go into that implementation, the background task DB. So here's the code for it. And we spoke about multiple threads or services trying to compete for the same resource, but that's not the only challenge that you face when it comes to dealing with race conditions and parallelism and all of that, because what if you're running multiple instances of the Raytha platform or whatever web application you're running? What if you scale out to 10, 20 services? Well, it's not just the instance that has multiple threads running on it, but you're going to have multiple instances of the actual application competing at the database level. And that's why we need to go and use Dapper, just basically raw SQL, to have some additional commands where we're saying basically lock the rows, and we only want one connection to the database to access those rows while the command is running. So this allows, if you have multiple instances, to not step on each other. So that's what this code is doing. It's basically saying, get me the latest background task, but I want to do it in a way where only one connection is making it at a time. Okay, now for the big piece, which is queued hosted service. We haven't spoken about this at all yet. So this is the background service that runs when we initiate the service. And we're injecting the service provider because we're going to need to make some calls. So here's this background processing function. So basically saying the execute function should just run this function forever, the background processing function. It should just keep on running. And we're getting the task queue here. We're getting the entity framework. And we're constantly checking every second. We're sleeping every second. We're constantly checking, hey, is there anything to dequeue? If not, then just skip and continue again. Is there anything to dequeue? Nope. Okay, just skip. But if there is something to dequeue, then we actually have a value in this dequeue task. So then we're going to get the background task details for that item. And this is going to create that actual type on the fly as an iExecute background task. This is why you need to implement this interface when you're creating a background task, because we're creating an instance of the object that you defined right here in this moment, and then we're executing it. And then here again, that deserialization to JSON elements. Now it should all come together because we're deserializing the args that you passed in and passing it as a function because we're executing it. And then when it's done, we specify that status is complete. If it's an error, we say that it's an error status. Otherwise, it's 100% completion time is UTC, and save it. Now to wrap it all up, we do have to specify these services in the dependency injection. So that's what we're doing here. And let's see what else we got going on. This is very important. So we're also defining it here, but I want to talk about this for loop for a second. So you see under configuration, num background workers. So what's going on there? If we go to app settings, by default, we're setting it to 4. Okay. So num background workers. So you can change that if you want more background services running, but 4 seems appropriate. Basically what this means is that you're only going to have 4 background services running at any given time. So if you have more than 4 items that are enqueued onto the background service queue, it's going to dequeue 4 and then process 4 at a time. So if there's 7 on the queue, it's going to take the first 4, and then as ones are finished, it will then, another thread becomes available, and then it will grab another one off the queue until all are processed. So you can change this. Really, it depends on the resources you have available on the server, you know, how many connections you want running, things like that. But 4 seems fine, but you can always up it or, you know, change it if you need. So that's going to do it for today's video. I hope you learned a lot about background task management in .NET. It's quite a bit to go through if you really want a robust and comprehensive system for running tasks, especially those that are fire and forget style from the user who needs to kick off tasks. But check out the Raytha platform. It's completely free, open source. You get all this code. You can build on top of it, build your own web applications, build your own websites. It's a great project. So check it out. Feel free to contribute. And we'll see you again in the next video. Thanks again.